right, so here is our last section for this unit, section 8.7, and these are systems of nonlinear equations. So what you're going to see is instead of just linear equations, you'll see quadratics. You might see some circles. And so before we get started in solving these, I'll just let you know they're very algebra heavy in terms of there's just a lot of quadratics to work through and things like that, a lot of distributing. If you're feeling a little overwhelmed by some of the questions on this section, it's okay. I know that some of them are a little bit more complicated in terms of just all of the algebra associated with it. And you really just kind of have to keep track of what in the world it is that you're even doing. So these questions really put a lot of the techniques that you know into practice into like one big question. All right, so before we get started, let's talk about the possible solutions that you could see as you're solving these. So if you have a linear and a quadratic, one of the possible solutions is your line could cross your quadratic and it could cross it at two different locations. And so you could have two possible solutions there. Or you could have a quadratic and your line could cross it maybe just at one location. And that's what we call a tangent line. And it would only hit the quadratic just once. And so it is possible to have one solution. Or you could have a quadratic and maybe you have a line going like this, and the quadratic and the line never cross, in which case you have no solutions. So as you're solving a linear and quadratic system, it is possible to have two solutions, one solution, or no solutions. And so as you're working, the algebra will dictate which one is which. So you don't necessarily have to know at the beginning how many you're going to have. The algebra will tell you along the way. All right, for a quadratic and a quadratic, here's your possible options. You could have a quadratic that goes like this, and maybe one that goes like this, in which case you would end up with two solutions. Or you could have a quadratic here and a quadratic here, in which case they only cross once, so you would have one solution. Or you could have a quadratic and another quadratic, and those quadratics don't cross at all. So once again, you could have two solutions, one solution, or no solutions there. And just like I said before, the algebra will dictate for you. It will essentially work itself out to having two, one, or no solutions. So you don't really have to worry about too much at the beginning of any questions how many possible solutions you have. But if you're working a quadratic system and you end up with three solutions, then something funny is going on, right? Because that's just not a possibility. All right, you could have linear and a circle, in which case if you have a circle, the line could go through your circle and it could cross twice. So you could have two solutions. Or you could have a circle and you could have a line hitting the edge of your circle. Once again, we do call that a tangent line. For those of you who are going to maybe take some calculus in the future, you'll use that phrase very often, a tangent line. Or you could have a circle and a line and they never cross at all. So it's possible to have two solutions, one solution, or no solutions. And then another type that you could see is a circle and circles. So let's say you have two circles like this. They would cross twice, so you have two solutions. You could have a circle, oops, a little goofy circle, and another circle, and they only touch right there on the edge. Those two circles would be considered tangent to each other, in which case you have just one solution. Or guess what? You could have two circles that don't touch at all, and those two would be considered no solution. So for all of these, it is possible to have two solutions, one solution, or no solutions. It is also possible for the quadratic systems to have all real solutions. So let's say you had a quadratic and then you had a quadratic right on top of it. Oh, sorry, you can't see that. You had a quadratic and then you literally had one that graphed right on top of it. That would be all real numbers. Or the same thing for circles. If you had a circle and another circle that literally graphed on top of it, you could have all real numbers there as well. So for both of these, let's go ahead and add a circle or a quadratic with a quadratic on top, or you could have a circle, right, with a circle on top. So for those two, you can add in the possibility of all real solutions. All right, so we're going to go ahead and get started with some of this algebra. There is a lot of algebra here, I'm not going to lie. As these get more and more complicated, the more and more algebra you're going to see. All right, so for this one, we have a linear and a quadratic. So this would be a linear quadratic system. So we have two solutions, one solution, or possibly no solutions, right? Those are our options here. So when you're doing this, you have to eliminate either a variable or you can do substitution. Most likely, you're going to do some substitution. If you don't have the same type of equations, like a line and a quadratic, those are different types, substitution will probably be the way to go. If you have the same type, like a quadratic and a quadratic, then then elimination might be the easiest because you have kind of the same variables going on. So for example, the fact that this is an x and this is an x squared, you can't just square this and square this and square this. That's not how squaring works, right? So you have to be really careful there as you try to do some elimination. So we're going to substitute. So I'm going to substitute the y in for the y because they're both equal to y. So I'm going to say x squared minus 4 is equal to negative x minus 4. And so this is just substitution, and then we're going to solve this equation. Because this results in a quadratic equation, you should set it equal to 0 and solve. So x squared, adding the x over, and then adding 4 would go with that 4, and then that would make 0, and it is equal to 0. So we still have to solve this quadratic. Because there's only two terms, that actually makes it easier to solve. You can use a quadratic formula, you could complete the square, and you can always factor, right? Those are your three options to give it a try. So because these two have a x in common, I'm going to factor, but I'm going to factor with a greatest common factor. So I'm going to take out the x, and left over is x plus 1, and that is still equal to 0. And so my two x solutions are x could be 0 from this x in the front by itself, and x could be negative 1 from that piece right there. So this will have two solutions, and that's because when we solved, we ended up with the two solutions there. Now you do have to take both solutions and go back and figure out your y. I would much rather put them in the first equation than that second one with the square, but it's completely up to you. You can put it into either. It's not going to matter. So if you plug in 0 here, you'd have negative 0, which is 0. 0 minus 4 is negative 4. So in that case, y is negative 4. So that coordinate point is 0, negative 4. And then if you plug in 1, you'd have negative 1, or negative 1, which would be positive 1. 1 minus 4 is negative 3. So then your other coordinate point is negative 1, negative 3. So you have two solutions, and here are the two places where this line and this quadratic cross. All right. Here's the next system. We have a quadratic and we have a quadratic. They're not set up like typical quadratics, but that's okay. Because of the x squared, that's how I know that they're quadratics. And the y doesn't have any variables on them, right? No variables on those y's. So you could set this up as y equals, ax squared plus bx plus c by doing some rearranging there. We don't have to rearrange it, though, unless we really want to. I don't really want to. I think we're set up in a pretty good form because they're set up the same way the equations are to go ahead and just do some solving here. Because they're set up really nicely like this, elimination is probably going to be your best bet. And you can either eliminate the x squareds or you can eliminate the y. It's up to you. I think eliminating the x squareds would work out well. So in order to do that, you do have to change the sign of everything in one of the equations. So I'm just going to change the first equation, and I'm just going to rewrite that. So that would be a negative x squared, a plus 2y, and a negative 26. So that's that first equation. All right, and adding those together, the x's are eliminated. We'll have 7y equals negative 35. Divide by 7, we have y equals negative 5. So we actually found that y value really quickly, didn't we? Once you know one of the values, you plug it into either of the equations and finish solving. So it's your choice if you want to put it into the first one or the second one. Completely up to you. Or you could put it into this one, right? Because that's an equivalent equation. So 100% your choice. I'm just going to pick this one right here. So I'm going to use that one. None of them are really easier than the others. I just picked one. So we'll have x squared. Plugging in 5, we'll have minus 25 equal to negative 9. And this is a quadratic, and I don't have any other x's, so I can use the square root property here. So I'm going to add 25 to both sides. So I have x squared equals 16. And then you can take the square root, and remember, when you take a square root, when you're solving, you have to include plus or minus. So there's your two solutions, the plus and the minus. One's positive, one's negative. So this is a two-solution quadratic system. It didn't come out when we were talking about the y, but it came out when we figured out the x. Because of that square root, you do have to include plus or minus. So if you don't include the plus or minus, you're only going to tell one of the two. So your two coordinate points would be at positive 4, negative 5. And then the other one is at negative 4, negative 5. Make sure that you put the right x and y's, right? X goes first, y goes second. It's really easy to do all this work, and then you put in the coordinate point, you put negative 5, 4, negative 5, negative 4, and then you have the wrong answers because they're backwards. So just be careful that you don't mess up that small little thing there. All right. Here is the next one, and the further we go here with these practice problems, the more algebra heavy they're going to get. This is a linear, and this is actually a circle because you have both x squared and y squared. So this is a linear circle relationship. And so we're going to solve this and figure out what our solutions are. This is not set up for elimination. We have an x squared and a y squared, and this one we just have an x and a y. You don't want to try to square anything over here. It's going to make it a lot harder. Trust me. What you'd much rather do is do substitution. So you're going to take this y and plug it in for this y. So we're going to take this value here and plug it in for that y value there. So x squared plus, and you do need to put this in parentheses, negative x plus 7 squared, because the whole thing has to be squared, is equal to 29. And so we're going to solve this equation. When you get rid of this square here so you can start combining like terms, you do have to distribute. This is negative 7 plus x times negative x plus 7 times negative x plus 7, right? You do have to distribute there. So please don't say x squared plus 49 equals, and then you're going to miss a whole term in the middle and you're not going to get it right. All right, so when we multiply this out, we'll have negative x times negative x, so that's a positive x squared. We'll have a minus 7x and another minus 7x, so we'll have a minus 14x, and we'll have a plus 49. So you would be missing this term in the middle if you just squared both pieces. That equals 29. All right, so combining like terms, it's a quadratic, so I'm going to set it equal to 0 also. So I have 2x squared minus 14x, subtract here, that's just plus 20 equals 0. All of these have a greatest common factor of 2, don't they? They all have a 2 in them. So what I'm going to do is I'm going to divide everything by 2 because I have it equal to 0. So as long as I divide each piece by 2, we won't change our solution. So x squared minus 7x plus 10 still equal to 0. So divide by 0, divide by 2, divide by 2, divide by 2, and yes, divide by 2. Okay. And this one is a lot easier to solve than this one because of the 2 being gone in the front. It factors, multiplies to be 10, adds up to be -7. That's -5 and -2. So we have x minus 5, x minus 2 equal to 0. So x would be 5 and x would be 2. So we will have 2 solutions here. One when x is 5 and one when x is 2. All right, and believe it or not, we're not done because we only know half of our solution. We only know the x's. So we have to go back and find the y's. So you're going to take these x's, plug them in for either equation. I would pick the first one and solve for y. So when you plug in 5, you'll have -5 plus 7, which is 2. So this y value is 2. So that coordinate point is 5, 2. And when you plug in 2, you'll have -2 plus 7, which is 5. So this y value is 5. So that coordinate is 2, 5. So this line crosses this circle twice at 5, 2, and 2, 5. By the way, that won't always be where they're just reversed for a line in a circle. So that's just a coincidence for this problem. All right, a little bit of a story problem here. So we have a point, or find the point in the first quadrant. So not just all points, but just the one in the first quadrant. And if you remember, the first quadrant is where x and y are both positive numbers, right? Where the line y equals 4x intersects a circle of radius 5 centered at the origin. And so one of our equations is y equals 4x. The other equation we're going to have to write, and we have talked about it in this class, how to write the equation of a circle radius 5 centered at the origin. And so because it's at the origin, it would be x plus 0 squared. And then you would have a y plus 0 squared. And then equals your radius squared. So your radius is 5, so 5 squared is 25. Which this equation you should simplify down to x squared plus y squared equals 25. That's going to make it a lot simpler. But just remember that is the coordinate points of the center, right? I'm going to get rid of that. So here's our 2 equations. We have y equals 4x and x squared plus y squared equals 25. All right, this is probably going to be best solved with substitution again because this is x squared, y squared. This is regular x, regular y. And so you can go ahead and substitute. So we'll have x squared plus, and you have to put the 4x in parentheses when you plug that in for y, equals 25. So x squared plus, and because there's no plus or minus in between these, it is just square both parts, all right? So 4 squared is 16, x squared is x squared, equals 25. X squared plus 16x squared, that's 17x squared. So x squared is equal to 25 over 17, which means we're going to get some not nice numbers here. And then you would take the square root, and when you take the square root, you should include plus or minus. All right, so this would have 2 solutions, right? One positive, one negative, except if you remember at the very beginning of this question, it just said find the point in the first quadrant. So we only care about where x is positive. So this plus or minus, you don't have to worry about the negative version of this. You're just going to use the positive just for this problem because it specifically says. If it doesn't say this, then you would use both the plus and the minus. All right, so we're going to go with just the positive version, and we have to find y. So I'm just going to bring an arrow way back up here. So x is the positive version, and I need to find y. You can either use the circle equation, or you can use the linear equation. Definitely want to use this one, right? Because you're just going to take this value and times it by 4. So it'd be 4 square root of 25 over 17. And so your coordinate point would be the square root of 25 over 17, comma, 4 square root of 25 over 17. And you only have one solution here because it's saying find the point in the first quadrant. If it wanted just the solutions, you would have to do the same thing with the negative as well, right? All right. Up next, we've got another circle and a line problem. I'm going to start it, and then if you want to hit pause and see if you can work through it, that might not be a bad idea. To start this, definitely going to want to use some substitution here. There's definitely no elimination that's going to happen very easily. So I can either solve for x or solve for y, completely up to us. The x is going to be a lot easier because I can say x is equal to negative 3y plus 7. I can just move that 3y over and use this equation instead. So you should substitute that x in here. So negative 3y plus 7 should go in for that x. So when you set this up on the substitution, you'll have that for your first one plus y minus 6 squared for your second one equals 180. So this would be a good point. You can hit pause on the video if you want to try to see if you can complete the algebra associated with this question. Even if you want to give it a shot and see how far you can get, and then go ahead and you can come back and hit play, and we'll work it out the rest of the way for you. All right, so let's go ahead and work out this problem. We can combine some like terms here. Negative 7 minus 19, that's negative 12 squared. So y minus 6 squared equals 180. And then you do have to distribute for both of these squares. So you're going to have to do negative 3y times negative 3y minus 12 times negative 3y minus 12. And then for this one, you are going to have to do y minus 6 times y minus 6. So multiply, 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 so much multiplication here. Negative 3y times negative 3y is 9y squared. You're going to have a minus 36y and another a plus 36y and another plus 36y. So that'll be a plus 72y and then a plus 144 from that first piece. This one will be a plus y squared, a minus 6 and another minus 6, so a minus 12y and a plus 36. And it is still equal to 180. All right, from there you should combine like terms. It is a quadratic, so I'm going to move the 180 over in the process as well. And then we'll solve the quadratic. So I have 10y. We'll have 72 minus 12, so plus 60y. So that was 10y squared plus 60y. And then we'll have 144 plus 36. That's 180, but then I'm going to move this 180 over, so subtract 180. So that's 0, and that will be equal to 0. All right, to solve this, I only have two terms, which is actually super helpful because now I can just use a greatest common factor. So these two terms have a 10y in common. Left over will be a y plus 6 equal to 0. So your y values are 0 from the 10y and then negative 6. All right, and last but not least, we're not finished. We did all of that algebra to find y, but once you know y, you can go back to one of your equations and just plug it in to find x. So you're definitely going to want to pick this one, right? So first one, plugging in 0, negative 3 times 0 plus 7 is 7. So x equals 7. So one of your coordinate points is 7, 0. Make sure you put them in the right order. And then plugging in negative 6, that would be 18. 18 plus 7 is 25. So, whoops, I wrote y equals 25. That's wrong. It's x equals 25. So this would be 25, negative 6 for your other coordinate point. So a lot of algebra associated with that, although it is all algebra that you can do. Like if I had asked you any of these pieces individually, you probably wouldn't have much of an issue with them. But then you did have to combine some like terms, you had some factoring, and then you did have to substitute those numbers back in. So it is just a lot of pieces to kind of pay attention to, and it can look kind of crazy there in the middle. All right, last one is another story problem here. We have if xy is a coordinate point on the circle x squared plus y squared equals 1, and the distance from point P, which has coordinates xy, that's what that means. It's a point P, xy coordinates, to 0, negative 1 is 1 over 7, then find the y coordinate of point P exactly. So I guess the good thing is we're just looking for the y coordinate, so you don't have to go back and find the x. The hard part is what in the world do we use for our equations, right? So the first equation is this circle, x squared plus y squared equals 1, right? They tell us a circle. The second one is going to come from the distance formula. And so if you remember, your distance squared, I'm just going to write your distance, is going to be your change in x squared plus your change in y squared. And so your distance would be the square root of that value there. This is the Pythagorean theorem, essentially, the distance formula is. And so we don't know x and we don't know y, but we can use this point as our x1 and our y1, and then we'll use 1 over 7 as our distance there. So let's go ahead and just set this up. So distance squared would be 1 over 7 squared. Well, 1 over 7 squared is 1 over 49. Equal to, you'll have x minus the x coordinate, and the x coordinate is 0. So that'll just be an x squared. Plus y minus the y coordinate. So that'll be a y. And then minus negative 1, because your coordinate is negative 1. So it'll be a y plus 1 squared. And so this is your distance formula. I just didn't mess with the whole square root portion of this. I just left it as distance squared because it was just a number that I was going to square. All right, and you have to solve this system here. So as we're solving this system, I noticed that I'm going to have an x squared, and then in here is a y squared. So this is probably an elimination. And so I'm going to go ahead and set up this bottom equation to maybe look a little bit nicer. So x squared y plus 1 squared equals 1 over 49. So I just rearranged this equation here, to set it up so it was in order to help myself out. And then these are going to work out really well as long as one of them becomes negative. I would rather make this one negative than try to make this one negative. So I'm going to take that first equation and multiply it by negative 1. So I took this equation, multiplied by negative 1. So here's my two equations that I'm going to put together. So we'll have x squared minus x squared, those will eliminate. Here, there is some like terms here, but I have to multiply it out first. So I'm just going to write it as y squared plus y plus 1 squared equals, and then if you put these together, that is going to be negative 48 over 49, because you can think of negative 1 as 49 over 49. So 1 minus 49 is 48, negative 48 over 49. All right, I'm going to work on this side and see what happens. Specifically, I'm going to distribute here. So y plus 1 times y plus 1 is going to give me a y squared plus 2y plus 2, negative 48 over 49. And then I do have that minus y squared from the front that I'm going to bring down as well. And I guess some good news is happening here. Negative y squared plus y squared means that the y squareds are going to go away. They're going to simplify each other to 0. So we're just working with 2y plus 2 equals this fraction. And from this point, you can just use your calculator to go ahead and tell you what the y value is. So you would subtract 2 and then divide by 2. So negative 48 over 49, subtract 2, and then divide by 2. And then you can turn it back into a fraction. So second fraction. This is a mixed number, it looks like. That's what the 1 and then that little u, so it's saying, whoops, sorry, there's a glare. It's 1 whole 1 and then 24 over 49. So whatever 24 plus 49 is over, oops, 49. So 73 over 49. And it was negative, wasn't it? Yeah, it was. Don't forget that negative. So that's just what I got when I subtracted 2 and divided by 2. And then going back to our question, remember it did say find the y coordinate of point P. And so there is your y coordinate. That's what y equals. So we are done. That's all we needed to find right there. So no need to worry about going back and trying to find the x. The x is going to look a lot more complicated, right? That's it for y. All right, and that is it for our notes for this entire unit. So that's the end of Unit 2. So as you're working on finishing your homework, let me know what I can do to help. And then up next will be your Unit 2 test.